Good morning, ladies and gentlemen. I am sorry that I don't get to be there at this moment with you right now. And so, in lieu of me, I'd like to talk to you a little bit via video about radicals. And remember, when we're talking about radicals, we're saying something like, the cubed root of x squared and converting those to rational exponents. And so if we wanted to convert that to a rational exponent, we would say it's x to the 2/3. Just a quick review on that. We remember that the top of that is really like the exponent or the power, okay? And we would say that the bottom part of that right here, well, that was kind of like really the root. And so we see that as we look at this because we go, this was an x squared, and so that 2 ends up in the numerator, the top of the fraction, and this cubed root, well, that ends up in the bottom of this fraction right here. Okay, and so that's just the real basics, and just to remind you. So what I'm going to do is I'm going to walk through 4 examples of the turning radicals to rational exponents. We're going to start with something really basic, and it's going to get a little bit more complicated every time. And then you're going to try some on your own. So let's take a look at exemple numero uno. So here we go. At example number 1, we're looking, and we have got the 9th root of x to the 5th. And man, does that sound gross. But ultimately, you think about it, and the 9th root is no different than the cubed root or the 12th root or the square root. It's some root that we're looking for. And it's of x to the 5th. And so as I look at this, this is a no work problem. I go from this to the answer. I see the 5 as the exponent on the x, and I see the 9 as the root. And so clearly, this is just equal to x to the 5/9. That's it. That's as far as we can go. Done. Okay? So with real basic, simple ones, we get to keep them simple. Let's move on. Okay? For example number 2. Now, example number 2, it starts to get a little bit more complicated in a couple different ways. First of all, we're multiplying things. Second of all, if you notice, we're multiplying different roots. We've got a cubed root and we have a quad root or 4th root. All right, so we're going to give this a shot. Now, the 5 and the 2 just get to multiply by each other. And so 5 times 2 is 10. All right, and then we've got to look at this and go, okay, this 3rd root of x is the same thing as x to the 1/3 power. And this 4th root of x is the same thing as x to the 1/4 power. And maybe we wish we could leave it there, but certainly we're not done. And we think about those rules of exponents, and we remember that if we had something like x to the a power times x to the b power, that was equal to x to the a plus b power. An example of that was if we had like x squared times x to the 5th, that became x to the 7th. All right, and so now what we're going to do is we're going to apply that rule to this situation. We just happen to have fractions. And I know fractions are a pain for a lot of people, but this is not too bad. Okay, so we've got 10x to the 1/3 times x to the 1/4. And if we are looking to add those like we did over here, well, then we need to find a common denominator. And the common denominator would be 12. So this is the same thing as 10x to the, 1/3 of 12. That would be 4. 4/12 power times x to the 1/4 of 12 is 3. 3/12 power. And now I can add those fractions because they have a common denominator. And so that would simplify to 10 times x to the 7/12 power. And so this whole mess right here simplifies down to just that. And that's as far as we can go. So while that looked really complicated and maybe even seemed a little bit hard because we were dealing with fractions and common denominators, ultimately it was pretty easy. All right, well, let's look at exemple numero 3. Now, last time we were multiplying, so now what are we going to do? We're going to divide. And again, notice we have a square root and we have a quad or 4th root. And so again, this is getting a little bit weird, but this isn't hard. So first of all, what I want to do is I want to go ahead and convert them to those rational exponents. And so I would look at this and say, well, the top would become xy to the 1/2 power. And the bottom would become 16xy to the 1/4 power. All right. Now, really at this point, it can get a little bit wacky. You go, well, what in the world am I supposed to do? Ultimately, I want to have them have the same root. I want them to be under the same radical. I don't know if you guys remember, but off to the side here, I can talk about, if we had the square root of a over the square root of b, we said that was equal to the square root of a over b. And sometimes that allowed us to simplify things. Like, for example, if I had the square root of 27, which I don't know, over the square root of 3, which I don't know, that was equal to the square root of 27 over 3, which is the square root of 9, which I do know. And that's just 3. And so here was a situation where when we had two radicals, one over the other, it can really simplify down to something really nice. And we want to see if this one will kind of work out the same way. And so it would be best for us if we could make it all one radical. And so to do that, again, I got to think common denominators, okay? And so I got to be under the same root. And so a 1/2 power, like I have right here, would be the same thing. 1/2 is the same thing as 2/4. So what this could simplify down to is this could be the same thing as xy to the 2/4 power over 16xy to the 1/4 power. And what would that mean? Well, that would mean they both are being raised to the something fourths, which means that ultimately it's a radical right there. And so you go, well, that would be the same then as the 4th root of xy squared, because we got to deal with this 2 right here, over 16xy. Because this one was being raised to the 1st power, so it doesn't have any additional thing going on. I'm kind of running out of space, but what I'm going to do is say, okay, I can go ahead and distribute this squared power right there and say that this is the same thing then to the 4th root of x squared, y squared, all over 16xy. All right. Now at this point, we finally get to start canceling some things out, some things simplify. We got x squared, y squared over xy. So clearly those squareds cancel out and the x and y cancel on the bottom. So these are gone. And so then we would be left with the 4th root of xy all over 16. All right. And then we know that 16 has an even 4th root. It's 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. And so that can actually come out. But it's in the denominator, so it has to come out as a fraction. And so that would look like this. It would be the 1/2, okay, times the 4th root of xy, which the 4th root of xy then would be the same thing as what? Well, it's xy raised to the 1/4 power. So all of this simplifies down to 1/2 times xy raised to the 1/4 power, or in other words, xy to the 1/4 power over 2. So this whole mess that we started with, this gargantuan, ugly mess right here, simplified all the way down to xy raised to the 1/4 power, except I should keep that in parentheses, over 2. All right. Well, now here we are at exemple numero 4. I'm going to give myself a little bit more room right off the get-go for this one. Okay, and exemple numero 4, if you look at this one, talk about ugly. We have the 3rd root of y times the square root of y. So again, this seems all sorts of ugly, but it's really not that bad. We got to think about what it was to raise a power to a power. And that's kind of what we have going on here, if you think about it, because we have this whole thing. You kind of say, well, another way of looking at this would be, this is the same thing as y times y to the 1/2. That's what this inside would convert to if we just looked at that. And this whole thing is being raised to the 1/3 power. Okay, and maybe, I don't know, maybe if that feels like I moved a little bit fast, I don't know. So let me maybe put like an in-between step there and say this is the same thing as, let's first just deal with the outside and say y times the square root of y, all this raised to the 1/3 power. Okay, and then we realize that the square root of y is the same thing as y raised to the 1/2. And so that's where I'm making this move from there to here. All right. But like I said, when we raise a power to a power, we multiply. And so right now what I can do is I can distribute this power, this 1/3, to each part. And it kind of becomes y to the 1/3 times y to the 1/6. 1/3 times 1/2 is 1/6. Okay, if you didn't know, 1/3 times 1/2, you multiply straight across. 1 times 1 is 1, 3 times 2 is 6. Okay? And now, lastly, I have to combine those two things. And again, to add them to add fractions, I have to have a common denominator. So if I'm multiplying here and I'd add the exponents, I got to have a common denominator. And so I would have y to the, now 1/3, that could be converted to the 2/6 power times y to the 1/6 power, which would leave me with, if I add those, to y to the 3/6 power, which is the same thing as y to the 1/2. Okay? Wow, which is really just the square root of y. But for these, we're going to leave them as a rational exponent. And I think it's pretty amazing that something as ugly and complicated looking as this would simplify all the way down to just that. Y raised to the 1/2. That's pretty amazing. All right, so we've tried these 4 examples. Let's look at them real fast again. These 4 examples where first we had a basic radical with something underneath the radical is being raised to a power, and we can convert that to just a rational exponent. Next, what we did is we were multiplied 2 things that involved radicals. When we did that, first thing we did is we had to kind of convert them to rational exponents, and then we had to find a common denominator and combine them. And that wasn't too bad. Next thing, we worked on dividing radicals. And again, our first step there was converting those radicals to those rational denominators. And then that helped us, then kind of move from there and make sure we, again, had common denominators there. And so we look at that, and then we were able to all put it under the 4th root, okay? And then things started canceling out, and this whole thing just got simpler and simpler until it was all the way down to here. And lastly, we took a radical of a radical. All right. We basically, it's in the same way of raising a power to a power. We took a root of a root, and we saw how that whole thing broke down real simply. Okay. The first thing we did was we changed the outer radical to a rational. Oops, I didn't want to do that. We changed the outer thing, outer radical to a rational exponent, and then we changed the inside into a situation involving rational exponents, and then we just distributed that outer power and brought it down and simplified all the way down to the bottom. Okay, so what I'd like you to do right now is, it is your turn. You get to try, all right? Your turn. So I want you to go ahead and turn to page 30 and look at numbers 74 through 88. Okay, it's not that many. All that is 8 problems, believe it or not, because I'm only asking you to do the evens. The 4 problems we worked through kind of go through the easiest and hardest of that problem set. And so I want you to give those a try right now. All right. If you need a hand, you can watch this video again or ask to watch this video again, and maybe that'll help you. But otherwise, hopefully I'll see you guys soon. Talk to you later.